I would like to speak my point of view about the university. What is the role of the university, and how can we make some change? What is the future of the university? And as in the title, what actually works? And the first question, so what is the role? Why do we need universities? Why we need universities? Do you know the answer? Why we need universities? Oh, why? AI generates code. Okay, so it solves a lot of problems. You know, you can use the AI, and of course, you know, the YouTube teaches faster. I mean, if you want to learn something, there are a lot of Udemy courses. There is a YouTube. You can download thousands of books or more, yeah, from different aspects. That's very important. So why you need the university? The GPT explains everything, right? So now you can ask the GPT, and maybe it can teaches you somehow for some material. So it works somehow. Technology, this is changes in every 6 months. I mean, okay, if you learn something in the universities, when you start your job, okay, you can forget 30% what you have learned. So what is the role of the university now? So something is changing, you know, and that's why we have to change the universities, the education. And this is what we are doing. And there is a gap, you know. So yes, yeah, you are working in the industry, or you are a member of some faculty, you are a student. So there is a theory from the university side, and there is the reality from the industry. And there is a missing gap. What? So what are we working with the university generally? So there are textbooks. I mean, you have to read textbooks, you have to learn, there are exams. So there are textbooks problems that you have to solve. What is in the industry? There are many undefined problems, right? When you start a project, when you start something, you know, there is a lot of uncertainty, and there are many undefined problems that you have solved. There is no, so there are many problems during the development, so that you have to solve. This is not equal with the university role. In the university, there are predictable tasks. I mean, there is a test, you have to do that, there is the exam. That's very predictable, you know, if I learn that, I can get 5. So that's very predictable. What is in the industry? There are many uncertainties. I mean, there is a project. Do you know what is the way? How can you solve the project? So there is some iteration if you want to solve the project. There is no predictable task, so that's less predictable tasks. So you have to work individually, mostly in the universities, right? What I mean, you have to learn that, go home, learn for the exam, after make the exam. Okay, you can get this diploma. That's very different when you have to work in teams, right? In the industry, you have to work teams, you have to lead a group, you have to define the problem, you have to make decisions, so that's very different. What is in the university? You have always correct answers. If you have a test, A, B, C, D, there is one correct answer, right? If you learn something, there is one correct answer. For the exam, you can get 100% if you find the correct answer. What is in the industry? The very important, the responsibility, right? That's the key word in the industry, instead of the correct answers. What industry really needs? So they don't need only specialists. Why I define you? For example, there are 2 different types of programs. The first, for example, if there is a microprocessor company who is coming to Page, right? They ask the university to make a top-down architecture. What does it mean? We define you need microprocessor developers. What you have to learn? What math, mathematics, some physics, and we can just build what you need. But these are specialized to something, right? The other, you have a wide range of basic knowledge, and you have 1 or 2 peaks that you have specialized, right? That's very important. So in the first case, if you teach the top-down architecture, in this case, it's very hard to change. right? You are not flexible. You haven't learned a lot of maybe soft skills. So instead of that's not good. So the industry need thinkers, right? Adaptable system thinkers. They have to think in systems. So if you want to make some development or you have to have an interdisciplinary knowledge. What I mean? So for example, if you learn only electronics or software engineering, how can you develop a software if you don't understand what is the role, what you have to develop, right? So you have to have a multidisciplinary knowledge. If you make a company, of course, you have to know about something about the business, about maybe a little bit about the psychology. So that's interdisciplinary knowledge. The specialization, that's not enough and very dangerous. Instead of you have to learn interdisciplinary knowledge, and very important, the communication from the industry part. What is the communication? For example, very simple, if you are a leader of a group and you have to define the problem very accurately. This is about the communication as well. How can you lead some group, a team, right? You have to communicate, right? And spread the information. That's very good. So it's very important. And how can you learn that? Because after the university, immediately you can do that. The rapid learning, of course, everything is changing. How can you learn and adaptable, learn the new materials? So you have to somehow adapt to the changes of the world. That's very important for the industry as well. So you have to learn continuously and very fastly. The AI-supported workflow now, so you have to, this is mandatory to use the AI sometimes. And you have to know now, actually, the AI-supported workflow, right? How can you work together with a GPT? This is not this is not easy if you have used that. So, but you have to know how can you use that. The system thinking. That's very important for the industry. You have to learn in systems, right? Ownership. Of course, in the industry, the ownership, that's an important role. Right? You have to think that you are an owner, you have an ownership, and you have to do a project, not just research or something. The ownership is very important. And the decision making under uncertainty. Of course, if you start a project, the uncertainty that's very high. You can't predict a lot of things. That's why that's very risky, but you have to make decisions. That's very hard. You know, if you have projects, it's very hard to make decisions when there is a huge uncertainty. Why this matters for me? Because I was working in the industry as well, but I'm teaching at the university. So in the last, 26 years, I was working in the oil industry, and I was working in the interdisciplinary field. I mean, mathematics, physics, IT, and so we have developed some machines in electrical engineering. So I worked over the world. And of course, we have founded the first spin-off company in the university. And that's why we try to make something between the industry and academic area. That's why I can speak about the industrial side as well, because I know both sides. So what the companies tell us? The first, they rarely complain about the missing formulas, missing equation. You haven't heard any time that, okay, you don't know that equation or you need that formula. That's very rare. So this is not for the universities. They complain about missing mindset. So instead of that's very important role for the companies, and there are a lot of students, we produce a lot of students with solving the predefined academic tasks. They can do it. They are excellent students, but struggle sometimes when they are facing open and with real engineering problems. But so sometimes there is a huge gap after they finish the universities. We have to fill this gap. I mean, when the student finishes, how can they immediately work for the industry with that soft skills that I have mentioned? So, now, the real world problem that I have told you, it's not follow the university structures. So the university structure, so that's a little bit different. And I can say this is the end of the isolated disciplines. So the interdisciplinary, that's very important. And the interdisciplinary engineering ecosystem. So I think for the innovation, this is the minimum requirement. Now, if you want to make an innovation, so you have to have an interdisciplinary knowledge. Without that, there is no innovation. Now think about that. If you can say any example that without interdisciplinary knowledge you can make some innovation, I don't know if you can tell something. I don't think. Okay, for example, AI and manufacturing, right? Maybe mechanical engineering and AI. That's an interdisciplinary knowledge. Robotics and biomechanics, or logistics, right? That's an interdisciplinary knowledge. This is just examples. Okay, if you are good on the data science, but you have to know about something about the healthcare, right? Both sides, they are required. Software, hardware, and human factors. Okay, if you have to make, for example, if you have to make a software for a hardware, but you don't know the hardware side, how can you develop a software? You have to know something about the electrical engineering, so on, and of course, maybe sometimes about the human factors. And for example, for the architecture, for the infrastructure, the cybersecurity, it can be connected. That's a interdisciplinary knowledge as well. Right? That's not multidisciplinary, this is interdisciplinary knowledge. Okay, what's the problem with the traditional education from my side? The first, they reward the correctness. That's the most important thing, the correctness. That's the reward. You can get mark 5 if you are correct, right? That's the most important thing. What is in the industry? They reward adaptability. There is no specification. Sometimes if you start a project, you don't have a very accurate specification. You just figure out how you start the project. But of course, yes, you have a plan, but no very, very specialized and detailed document. There is no correct answer. So of course, if you start the project, you don't know how can you go through the project, because there will be many problems that you have to solve. So you don't know how can you solve the project, how can you finish your project. Previously, you can define it correctly, right? That's why you have to make a continuous iteration. I mean, there is a problem, you have to change something, and you iterate. And what is the end of the iteration? The project is solved, and this is succeed perfectly. And you need the real responsibility. And what we have to teach, for example, learn continuously. So I mean, as you know, this is a common word. You have to learn continuously, but what is the learning? You don't have to use textbooks. I mean, if you are participating in projects or some maker spaces, that you can learn, not just from textbooks, right? Collaborate across domains. This is the interdisciplinary. So you have to work with interdisciplinary groups, right? You have to work together with the electrical engineers, with the management, and something about the project. So you can't work individually. So you have to validate your ideas. If you have an idea, that's not enough in the university. You have thousands of ideas, but just make an innovation from the ideas. That's a different role, right? How can you get the technology level, for example, 4, 5 from an idea? That's a very different role. How can you build systems, right? We are not speaking about projects only. This is about the system, right? How can you build a system? This is another role. How can you communicate professionally, right? So we have to teach how can you communicate, the soft skills. That's very important. So if you haven't presented any time, after you have to speak with somebody, that's missing. How can you communicate? This is with the, because you are so if you are the interface between the company and other companies, that's why you have to communicate professionally. Prototype rapidly, of course. So if you have to make prototype, you have to learn how can you do it rapidly. solve real problems. So we can figure out many problems from the university, theoretical problems, instead of get some problems from the real industry, right? And solve that problem. So we have to connect somehow the industry. I will show you how. So we have to involve the universe and the industry to the universities, and transform theory into decisions. See, if you have a theory, I have learned it, but this is not equal with the decision. If you have to make a decision, that's very different from the theory. If you know the theory, maybe later when you will be in the industry, you can't decide, but you have the background, but this is very different. Okay, the first is the project-based education. That's very important, the projects. So this is not a trend, this is the survival for the universities. If we keep just the lectures, and the practice, and do it alone, so that's not enough. So it kills the universities. So we need real projects. What creates the real project? Responsibility, ownership, teamwork. Of course, you have to work in team. Engineering thinking, right? Because that's the engineering thinking, because you have to build, you have a project, how you start, you have to make a plan, you have to make you have to plan your project after, so that's the engineering thinking. Okay, when the theory becomes real, so after the third presenter will be Berta Mach. She's a very talented student from our biomedical engineering program. And this is very important. It's an interdisciplinary program as well. And this is a very successful program. And we have 3 students from this program here. Thank you for coming here. And so that's very interdisciplinary. So there are many projects. There are many industrial projects and from research groups. And they start a project at the second semester. And they are doing it 3 semesters, and they are working together with companies, with research groups. That's very important. And of course, they publish, and they know the soft skills, and they do those projects. So that's very important, I think, in the new role of the university. How can we connect the industry and the university? So we have to involve the companies, because the industry provides real problems. So we don't have to figure out what is the problem. They can generate real problems for the universities. Constraints, validation. So they can validate the project from outside. That's very important. The university, what can you provide the university? They can provide deep understanding, research mindset, experimentation. So we started something. My idea is not about just the university or faculty, or program faculty university. This is more. This is about page. As Peter said, so we have to build some network here. I was here a very nice presentation 1 month ago. It was from Gergő Csikos, and it was about how can we build something in page. I mean, together with the industry, with the academic area, and because this is the future of the page, if we can work together. So that's why the university and the industry, they must work together. So this is where we try to make makerspace. I will show you, and students become contributors, and there is an interdisciplinary collaboration. And it will be natural to work together with a medical doctor, with a physicist, with a mathematician, with an industrial partner. So it becomes natural. So what we want to make a hub when involve the students to make a hub and involve the partners. We define makerspace. You know what is the makerspace? If the industrial partners and the university make open spaces, then you can go there, try something, make a project. So that's the open spaces. Then you can go, for example, if you're a citizen here, if you have some ideas, maybe you can do there and check what is the research there. Or if you have a research, you can do that there. That's very important. And this is together with the industry. Industry collaboration. We have a lot of external departments, and I have many ideas. How can we involve the real industry partner and make together something that can be seen from south of the Balaton, I mean South Dunántúl, it's called this region, you can see there is an innovation center in Pécs. And we can involve the students, the PhD students, industrial partners, and of course the Webstar as well. We have spoken about. Okay, what is the student perspective? The real experience, that's the most important. They have to get real experiences. So the theory, this is very important to understanding the principles. That's very important. They have to learn that. And in the experience, you have to make projects, you make hubs, makerspaces, and you have to apply your knowledge in the real world. The problem is coming from the industry. So what can we do? Research together with the industry. There are some research projects, industry collaboration, interdisciplinary teamwork, real responsibility. That we can do. So I think the universities evolve from knowledge providers into innovation ecosystem. So the innovation is a key word. That's the next step. If you have project, after how can you be innovative? How can you make a spin-off companies? And how can you make an acceleration, for example? How can you, if you have good ideas, you know, we have discussed the idea, that's nothing. You have to turn the ideas into a project. So that's two different things. Challenge, collaboration, prototype, iteration, and impacts. That's the order. And of course, the AI changes everything. And universities must prepare the students. And the AI-assisted workflows, we have to do that. Rapid technological change, of course, it changes the technology and continuous rescaling. That's very important because the AI, you know, that's grows rapidly. And the theory matters, reality decides. So the future engineer must understand both sides. Thank you very much.